Hi, I'm Dr. Austin Hitt, and welcome back to Into the Cortex. The focus of this episode is the second condition of science thinking, which is science explanations are often incompatible with our common sense notions of the world around us. In order to demonstrate this condition, I will use the science concept of a vacuum. To start, let's look at a vacuum using a familiar piece of equipment, a vacuum cleaner. You've likely had many practical experiences using a vacuum cleaner in order to clean your home. Most people see the vacuum cleaner as sucking up the material on the floor or furniture. If this is your conclusion, then you're incorrect. Research in science education reveals that children and adults maintain the misconception that a vacuum sucks or pulls up objects toward it. The correct scientific explanation is that vacuums do not suck up materials. Instead, matter, like air particles, push inwards towards the vacuum. The reason that children and adults have such a misconception about vacuums and many other natural phenomena is that they cannot directly observe the underlying causes of those phenomena. I think of this condition as being analogous to a famous scene in the movie The Wizard of Oz. After Dorothy, Scarecrow, the Tin Man, and the Cowardly Lion vanquish the Wicked Witch of the West, they present the mysterious Wizard of Oz with the witch's broomstick. They then ask Oz to make good on his promises of a brain for the Scarecrow, a heart for the Tin Man, courage for the Cowardly Lion, and a trip home to Kansas for Dorothy. The mysterious Oz is unmoved by their request. Instead, the wizard appears angered and intractable. At first, it seems that Dorothy and her companions will have to give up and leave. That is, until Dorothy's little dog Toto pulls back the curtain of a booth located at the periphery of Oz's chamber. When the curtains are open, Dorothy and her friends discover that the mystical Wizard of Oz is an illusion. He's just an ordinary person who is using machines and smoke and mirrors to create a facade of a great and powerful wizard. The scene from The Wizard of Oz is analogous to the situation that students face when they're learning novel science content. Often they observe demonstrations or complete activities designed to teach them about the phenomena and develop science concepts. However, most instructional demonstrations and activities will not directly reveal the causes behind the phenomena. In order to understand the cause of a phenomenon, students have to pull back and look behind it. They have to create models that will allow them to visualize how and why the phenomenon occurs. Now let's examine how models can help people visualize the concept of a vacuum. This demonstration uses a plastic vacuum chamber, a syringe with rubber tubing, and a balloon partially filled with air. First, I'm going to connect the syringe to the base of the vacuum chamber. Next, I will place a balloon on the base of the vacuum chamber. Now, I'll place a lid on top of the base. Notice how easily the lid comes up and down off of the chamber base. Next, I'll pull out the stopper of the syringe several times. This will remove air from the inside the chamber. What do you think happened? The scientific explanation is the removal of air from inside of the chamber produced a vacuum. By definition, a vacuum is a space in which there is no matter present. In this demonstration, the salient type of matter that was present and then removed to form the vacuum is air. I have now explained what a vacuum is, but it is entirely possible you still do not have a conceptual understanding of this phenomenon. In order to conceptualize a vacuum, you need to be able to visualize it, and to do that, you need to create and internalize a model of a vacuum. First, let's re-examine the vacuum chamber experiment. For now, we'll not include the balloon. Now let's create a model that will help us visualize what's going on. The first step is to imagine what the air particles inside and outside of the chamber look like. It is not critical that the model looks exactly like the target phenomenon. The primary purpose of a science model is to explain how something occurs. So for our model, we'll use something simple to represent air particles. Let's say circles. Now we need to represent the air both outside and inside of the vacuum chamber. Outside of the vacuum chamber are innumerable air particles. Likewise, there's a similar concentration of air particles inside the vacuum chamber. This is because some of the air in the room is captured in the vacuum chamber. Now, let's create a model that depicts the air inside and outside of the vacuum chamber after the air has been pumped out using the syringe. As in the initial situation, there are many air particles all around the outside of the vacuum chamber. However, the inside of the vacuum chamber is now devoid of air particles. This means a vacuum is formed within the chamber. Now that you can visualize a vacuum, the next step is figuring out how it works. In other words, determining why the vacuum appears to suck or pull objects towards itself. We can gain some insights into the nature of the sucking phenomenon by removing the syringe from the base of the vacuum chamber. Now watch and listen carefully. So what happened? What do you think caused the hissing noise? Again, we can use the simple models to explain what happened. Outside of the vacuum chamber, there are a lot of air molecules. Inside, there are no air molecules. When the syringe is disconnected from the vacuum chamber, the air outside rushes in. That is what creates the hissing sound. As a result, the amount of air particles inside and outside of the vacuum chamber is the same. It is balanced. Because the push or force of air particles is now balanced, they cancel each other out. This is why the lid of the chamber is no longer stuck in place. Now that you can visualize a vacuum and the resultant suction, you're ready to tackle the balloon problem. What happens to the balloon as the air inside the chamber is removed and a vacuum forms? Ready? Go! Take a few moments to see if you can figure it out. I'll give you a small hint that can help you explain the phenomenon. Create an air particle model depicting the air in the chamber and inside of the balloon. Before the vacuum forms, there are more particles inside the chamber than there are inside of the balloon. The greater number of air particles in the vacuum chamber means the particles inside the balloon get pushed around and their motion is highly constrained. However, when air particles are removed from the vacuum chamber, the air particles within the balloon are less compressed and can move more freely. Thus, the balloon expands. Now watch what happens when the syringe is removed from the base of the chamber. The air outside the chamber comes rushing in, and now there are more air particles pushing the air particles within the balloon. Subsequently, the volume of the balloon decreases. Now let's revisit the vacuum cleaner and see if we can explain how it works. When you tap on a switch of a vacuum cleaner, a pump is turned on. This pump removes air from a chamber inside the machine and creates a vacuum. The number of air particles outside the vacuum are therefore greater and move in towards the vacuum chamber. The inward rush of air, outside air, pushes dirt and other materials into the vacuum. Voila! You now understand how a vacuum cleaner works. In this episode, you learned that because science concepts cannot be observed directly, it is essential for people to create models so they can visualize them. Because models and model building is so essential for the development of robust science understandings, we will investigate science models and modeling in greater depth in the next episode. Until next time, keep on sciencing.